So our main goal is going to be to understand all the different types of functions that we're going to be working with later this semester. And in order to do that, the first thing we're going to have to do is decide what is a function. So that's our first title here. I will write DEF as an abbreviation for definition. And so what do we mean when we're talking about something being a function? We say y is a function. And I'll usually try to underline the word that we're defining. A function of x if for each input x, so x is the thing that's going into the function. So maybe if you've one time studied about a function as being like a machine, x is the thing that you're putting in. And now you should be thinking to yourself, what is it that's supposed to be special now? We say that y is a function of x if for each input x, there is what? There is supposed to be exactly one output y. And you might have seen this stated in a different way. You might have said that for each input x, there is a unique output y, or it might not have used the words input and output at all. The words input and output aren't crucial. It's just to help us understand how the function works. We put in the x, and out comes the y. And then we need a couple more words. So there's the set of all the things that we can put into the function. So the set of all inputs x, I think you know that this is called the domain. And then, of course, if we have a word that describes the set of all the inputs, we must have another word that describes the set of all the outputs. So the set of all outputs y is, and I hope you've seen this word before, is the range. And then the last thing we want to say about functions, well, not about functions entirely, you're not going to get off that easy. We have a lot of work to do with all the different types of functions, but about just what it means to be a function is that we have a very nice notation for functions that you'll notice we haven't used yet. And the notation for functions, we write y equals f, left parentheses, x, right parentheses. And as we'll see this semester, having good notation really makes a big difference in a math class. If you have bad notation, it can be confusing, especially if this catches on, and we might see an example of that later today. But here it really looks like you're feeding the x into the function and the y is coming out, right? So the x is the input. The f is the name of the function. So here, of course, we're just calling it f as a generic example, but the name might be something like sin to stand for sine. So the name of the function. And then, of course, the y is what comes out of the function. And every once in a while, I'll give you a little historical aside in this class, and you're never going to be tested on it or anything, so don't worry about it. But if you're interested in the history behind it, this particular notation came from what some people will call the greatest mathematician of all time. The name is pronounced Euler. It might not look like it, but that's how you say it, Euler. He gave us this notation in 1734. And we should really be grateful for this notation, because try to imagine what would we like to do without this notation. It would make working with functions a lot more complicated. All right, so I hope you've got an idea about what it means to be a function. And now that we've done this, in our next segment, we will look at the first type of functions, linear functions.